Alright, so some more quadratic applications. An area along a straight stone wall is to be fenced. There are 600 meters of fencing available. What is the greatest rectangular area that can be enclosed? Alright, so let's give ourselves a little diagram. Here's my stone wall. I'm putting in a fence along the stone wall. So my fence is not going against the wall, but all the other sides. There is 600 meters of fencing available. So my perimeter is going to be 600. So I'm going to have some distance here, x and x. The fence will be the same length here on both of these sides. And I'll have a distance of y here. So the perimeter in this problem is going to be 2x's plus a y. What is the greatest rectangular area? We're talking about area here. So the area of this fenced and enclosed area is going to be just x times y, or length times width, but since we're in terms of x and y, we'll say x times y. What do we know about the perimeter? The perimeter is 600 feet. So we got 600 equals 2x plus y. Now this should be similar to a system of equations. We're going to use this through substitution. So we want to change this equation so we can substitute and plug it into this equation. So we can solve this equation for y. So we can say y equals 600 minus 2x. Just bringing the 2x over to the left side. Once we have done that, let's take this equation and substitute it in. So we got the area is equal to x times y, and our new y here is going to be 600 minus 2x. This is going to create a quadratic for us. So if we FOIL through or distribute through, we're going to get area equals 600x minus 2x squared. It's asking for the greatest rectangular area, or the maximized area. So if we're looking to maximize this area, this picture-wise is a quadratic. So we're looking for the vertex. Okay, so what is the x value that goes with that vertex? So let's take this equation and find the vertex here. So we're going to say x equals negative b over 2a, which is my formula to find the vertex. My b here, be careful for the order. The b here is 600. So negative 600 over 2 times a, which is negative 2. And if we do negative 600 divided by 2 times 2, we should get an answer of 150 meters in this case. Now that's the x value. So this is going to be 150. This is going to be 150. And I have 600 meters of fence. So you could look at the diagram or the drawing and say, okay, if this is 150 and this is 150, that's taking up 300 meters of my perimeter. So then my y has to be also 300 to finish off my 600. Or you could go back and plug into this equation. So you could say 600 equals 2x plus y. So let's do that here on the side. So we could say 600 equals 2 times 150, substituting in for x, plus y. So 600 equals 300 plus y. Y equals 300. The question, going back to the question, says what is the greatest rectangular area? So my area is going to equal 150 times 300, and you should get an area of 45,000 meters squared. Second example, a rectangular picture is 13 by 15 inches. A frame of the same width all around has an area of 93 square inches. What is the width of the frame? So let's get a visual for ourselves here. So we have a picture frame which is 13 by 15 inches. So this is 15 by 13 inches. And then I have a frame that surrounds us, and it has the same distance all the way around. So it's going to be the same distance all the way around. So the distance from here to here is x. This distance is x, this distance is x, and this distance is x. Okay, so the distance all around the frame is x, or the same. And it has an area of 93 square inches. So this distance has an area of 93 square inches. So if we think about this for a second, how do I find that area? So to find that area, I want to take the area of the big rectangle, so the whole area of this whole big rectangle. I'm going to subtract the area of the small rectangle. So I'm going to be subtracting this piece here. And when I do that, I should get an area equal to 93 square inches. So to find the area of the big rectangle, I need a length times a width. To find the area of a small rectangle, I need to do length times the width again, and that'll equal 93. The question becomes is, what is my length of my big rectangle here? So if you notice here is, this is 15 from here to here. What else is in this rectangle? So I have this x here. So 15 plus that x, 15 plus that x, so I got 15 plus 2x. And then my width from here to here, I have 13 plus that x plus this x. So here is 13 plus 2x. So the length and width of this is going to be 15 plus 2x times 13 plus 2x minus. Now I want the length of the picture here. Well, that's already given to us. We have the length and width of 15 times 13. So this is going to be 15 times 13, and that will equal an area of 93 inches, or square inches. So the rest of this is just to simplify. 15 times 13, we get an answer of 195, plus 15 times 2x, 30x, FOIL, plus 26x, plus 4x squared, minus 15 times 13, which is 195, that worked out nice for us, equals 93. So my 195s will simplify, because I have a positive 195 and a negative 195. My 30x and my 26x will give me 56x plus 4x squared equals 93. Okay, so I want to solve this quadratic. I'm going to bring the 93 over. So this is going to be 4x squared plus 56x minus 93 equals 0. Okay, here you want to find the roots. You can use one of three methods: completing the square, quadratic formula, or factoring. So in this case, this actually factors. So this is going to be 2x minus 3 and 2x plus 31 equals 0. Solve these both for x. X here equals 3 over 2. X here equals negative 31 over 2. I can't have a negative distance, so we're going to x that one out, leaving me with an x value of 3 halves, or 1.5 inches, I believe. 1.5 inches. So the distance from here to here is 1.5 inches. So the width around the frame is 1.5 inches. The question is a little tricky. If it's somebody actually in the other class said, what if they're looking for the entire width? So you could be looking for the entire width as well. So if you are, then you're going to have 15 here. I'm sorry, that's the length. If you're looking for the width this way, it would be 13 plus 1.5 plus 1.5, and you could do a width of 16. But I think this is what the question's asking for. The width around is 1.5 inches. A ball is thrown vertically upward with an initial velocity of 80 feet per second. The distance s in feet of the ball from the ground after t seconds s equals 80t minus 16t squared. This problem is nice for the simple reason it gives you the equation already. Okay, you don't have to worry about what gravity is. You don't have to worry about what the upward initial velocity. Okay, if it's upward, is my initial velocity positive or negative? Positive. Okay, be careful. So if it's downward, then you know you're going to have a negative initial velocity. And 80 feet per second, and the distance. Okay. For what time interval is the ball more than 96 feet above the ground? So if we think about this. So if here's our graph, the ball is going to have, it's going to be starting here, it's going to rise, come down, and if there's going to be some height that's going to be 96 feet, that this ball will be above 96 feet. Okay, so sometime t, t1 and t2, this ball will be above 96 feet. So the question I would ask myself is, well, when does it equal 96 feet? When will the ball be exactly equal to 96 feet? So that says, let's take our equation, s equals 80t minus 16t squared. Well, if I want to know when it equals exactly 96 feet, Well, 96 feet is the height. S is my height, so let's plug in 96 in for S. So I have 80t minus 16t squared equals 96. And now this is, since I'm plugging in 96, when I solve this for t, this will tell me the time when the ball is 96 feet in the air. So solve this for t. So let's get everything over to one side. Since my t squared is negative, I'm going to bring these over to that side. So I'm going to have 16t squared minus 80t plus 96 equals to 0. And again, when I solve this for t, it will give me the seconds that it takes to be 96 feet in the air. 16, 80, and 96. Nice. 16 goes into all of them. Factor out 16 out of all of these. What am I left with? T squared minus 5t plus 6 equals 0. Factor this. Factors of 6, positive 6, going to give you negative 5. T plus, t minus 2. And t minus 3. So 16 times those two quantities equals 0. Set these all equal to 0. Those 16 will factor out. So I have t equals 2 and t equals 3. So when t is 2 seconds, it will be 96 feet in the air. When t is 3 seconds, it will be 96 feet in the air. So the question is asking between what intervals, for what time interval is the ball more than 96 feet in the air? So you're going to say, the question will then say, the answer will be between 2 and 3 seconds. So the ball will be in the air between 2 and 3 seconds. Okay, if it's at 1.5, it's going to be below 96. If it's at 3.5, it's going to be below 96. So you want to focus in on just this piece here of your parabola. Second part of the question is, what is the maximum height? Okay, so this maximum height, we're looking for the vertex of your parabola. Okay, so I'm looking for the y value of the vertex. So let's minimize this piece here. What is the maximum height? Let's use our equation again. Our equation was S equals 80t minus 16t squared. Looking for the maximum height, so let's find that vertex. X equals negative b over 2a is the form that I'm going to use to find the vertex. B in this case is what? Be careful with the order. Okay, so b is going to be negative 80 over 2 times negative 16. And if you have negative 80 over 2 times 16, you get what? Negative 80 over negative 32. What's negative 80 over negative 32 simplified? 5 halves, or 2.5. So in 2.5 seconds, I'll reach my maximum height. But the question is, what is the maximum height? So go back and plug in. So S equals 80 times 2.5 minus 16 times 2.5 squared. And I get an answer of 100 feet. So the maximum height here will be 100 feet. And then part C says how many seconds does the ball reach the maximum height? So this is going to be the 2.5 seconds that we found before. So after 2.5 seconds, it will reach a maximum height of 100 feet.